So in this question, this equation is given and it says this v is the velocity. So this is velocity. So what will be its dimension? Simple, length divided by time. There is no mass here, so this is m to the power 0. So dimension of v will be this, right? Now we apply the rule of dimensions. That is, if we have an equation, then the dimension of left hand side must be equal to the dimension of the right hand side. So that means the dimension of this whole right hand side must be this. Now if you look here, there is a plus sign here. So that means the dimension of this term and dimension of this term must be the same, because the rule is we can only add two quantities of the same dimension, and when we add them, the dimension of the result will be the same. So that means the dimension of this will also be this, dimension of this will also be this, right? Now in the question we have to find the dimension of A, B and C. So first look at the expression and see if there is another plus somewhere. In this question there is a plus here. Since this is a plus here, it's an addition, that means the dimension of C must be equal to dimension of this T. T is time. So that means dimension of C must be equal to T to the power 1. Right? Because C is added to time, so dimension of C must be time. Now once you have found out the dimension of one of the unknown, immediately look at the options. You will see there is only one option, option A, where the dimension of C is given to be this. So the correct option for this question is option A. If you do this, you will save a lot of time. You don't have to find out the dimension of this and dimension of this, because there is only one option where the dimension of C is given as T to the power 1. Clear? So that answers this question. But say in another question, there were two options where the dimension of C was given to be T. Then you will have to find out the dimension of A and dimension of B. So let me teach you how to find the dimension of A and dimension of B. So first let's find out the dimension of A. So dimension of AT must be equal to this. So this is m0 L1 T to the power minus 1. So that means dimension of A will be, see this is AT. T means time. So time we can write it like this. Okay. So dimension of A will be this T we can transfer to that side. So what happens is this m0 remains as it is, L1 remains as it is. This T to the power 1, when it goes there, it becomes T to the power minus 1. So there is already T to the power minus 1 here. So this will be T to the power minus 2. Clear? Simple, similar to the divisions of algebra. When you take this T to this side of the equal sign, it will come to the denominator. That means it is dividing it. So this will become T to the power minus 1 minus 1. So it will become T to the power minus 2. Clear? So see the option A, where the dimension of this A is given to be this. Right? Now if we have to find the dimension of B, how do you do it? We can do it like this. So dimension of this whole term is this. So m0 L to the power 1 T to the power minus 1 is the dimension of this. When you say dimension of this, so this is dimension of B and dimension of this. This is time plus time, result is again time. So this is dimension of time. Now we have to find the dimension of B. So dimension of B, I keep it to the right of the equal sign and I transfer this to the left hand side of the equal sign. So this will get multiplied here. So this becomes m0 L1 t to the power minus 1. When it comes here, this is plus 1. So this is what we get. So that means this will be m naught L to the power 1 t to the power 0. So this is a dimension of B. So if you see option A, this also matches. This way we can find out the dimensions of all these three quantities A, B and C if needed be. Okay.